Factoring and GCF. Factor, it's any number that divides a given number. A prime number is a number with exactly two factors, one and itself. So examples are 2, 3, 7, 11, and 13. Okay? Composite numbers are numbers with two or more factors. So 4, 6, 8, 9, 10, 12, and 14. Now the reason these are composite numbers is because 4 factors into 2 times 2. 6 factors into 2 times 3, or 2 times 2 times 2. Are y'all with me? Okay. No, not 2 times. It's just 2 times 3. Okay. So list all pairs of prime factors and circle the prime factors. So I'm actually going to use 2 different colors. Here we go. So my first number is going to be 108. Whoopsie. Are y'all proud of me? I didn't use white out. Okay. 108. Now I'm going to factor 108. Now you can factor it any way that you want to. I always start with 2 times what, or 3 times what, or if there's 2 factors that automatically pop in my head, I use those. So our factor trees might be different, but at the end they're going to be the same. Does that make any sense? Okay. So 108, I automatically think of 4 and 27. So then here, 4 is 2 times 2. Now let's factor 27. Well, that's going to be 3 times 9. And then 9 is 3 times 3. So I just circle. And those are, remember, those are my prime numbers, so those are my prime factors. 2 times 2 times 3 times 3 times 3. I just factored 108. Okay. Number 36. 36 is 2 times 18. 2 cannot be factored anymore, but 18 can be 2 times 9. And 9, 2 doesn't go into 9, but 3 does, and that is 3 times 3. So I just circle what is at the end of my factor tree. 2 times 2 times 3 times 3. That is how you factor. Everybody good? All right. Okay. You're fine. Find the greatest common factor. So we're going to find the GCF. So if you're given groups of numbers, the first thing is you have to list out the prime numbers, the prime factors of each number. Okay, so that's what we just did. We listed out all the prime factors of one number. So now we're going to list them out of each number. Then we're going to highlight the prime factors each number has in common. And we're going to write the factors that they have in common, and we're going to multiply them. All right? So let me show you how this is done. So if we have, our two numbers are 48 and 72. All right? So 48, I know, factors into 4 times 12. If you start with 2, that's fine. You can do 2 and 24. You start with what you want to. And then here, 4 is 2 times 2. And 12 is 2 times 6. Now 2 is a prime number, prime factors, but 6 can go to 2 times 3. All right. So 2, 2, 2, 2, 3. So my prime factors for 48 are 2 times 2 times 2 times 2 times 3. Is everybody okay with that?
I did 3 times 4.
Okay, so 72, I start out with 8 and 9. Remember, we can start out with different numbers. 8 is 2 and 4, and 4 is 2 times 2. Is everybody okay with the factor tree? Yes? Okay. And then 9 is 3 times 3. So my prime factors are 2, 2, 2, 3, and 3. So it's 2 times 2 times 2 times 3 times 3. Now, pay very close attention. This is very difficult. Are y'all ready? The greatest common factor. Watch. I have a 2 here and a 2 there. So, GCF equals 2. I have a 2 and a 2 times 2. I can mark off another 2. Now, can I mark this 2 off? No, because I don't have another 2 over here. Okay? What about the 3? Yes. 3, 3. What about this 3? No, because it has to be the same factor in both of them. So then what you do is you say 2 times 2 times 2 times 3 is 24. Your greatest common factor is 24. You're done. It's not near as difficult as what it looks. The factor tree takes time to write out. And there's some problems that I can see them, and there's some problems that I can't, so I'll make my factor tree over on the side. So with your assignments, if you do like a scratch piece of paper and you're just doing random factor trees, it's up to you, okay? All right. So now let's find the greatest common factor of a given monomial. Okay. So first we're going to find the prime factors of the coefficient. And then we're going to factor the variable. So we're going to do what we just did and factor the variable. All right. So if I give you 30, a squared, b squared, x. All right. Actually, it's very easy. I promise. Okay. We're just factoring one monomial by itself. What is the first step? Y'all can talk. What's the first step? Say it again. Yes. Find the prime factor of the coefficient. What's my coefficient? 30. Okay, so I'm going to write out 30. 30 is 6 times 5. 5 is a prime number. Okay, but 6 is going to be 2 and 3. So my prime factors of 30 are 2 times 3 times 5. Okay, now I'm not done. So step 1 is done. Okay, you're going to find the prime factors of the coefficient. Now it says factor the variables. Well, how do you do that? Times A. Isn't A squared 2A's?
Yes.
B squared is times B times times X. You want to take this and write it. And to me, when you're doing this, you're writing it in extended form. You know, they have it simplified, and now we're writing it in extended form. You all okay with that? Okay. So here, let's do 20ax cubed. Now remember, we're not combining these. We don't have 2. We're just dealing with one monomial. So the first thing I have to do is I have to factor 20. So I'm just going to start right there and factor. So 2 and 10. 2 and 5. So my prime factors of 20ax cubed are 2 times 2 times 5 times a times x times x times x. We're good, right? Okay. So, now remember, when we first started, we found the greatest, first we just factored a number, correct? Then we factored a set of numbers and we found the GCF, right? That was the second part of our notes. Here we just factored a monomial. So now we're going to find the GCF of 2 monomials. Same process as what we just did with the numbers. Okay? So here we go. Our monomials are going to be 3x squared and 9x cubed. Now, I'm going to warn y'all, I tried the best I could to reduce these notes, but to still leave room for us to write, so don't write too terribly large on these, okay? All right, so 3x squared. Well, can 3 be factored? No. So this is 3 times x times x. I can't do anything with it except expand the x squared. All right? Now what about 9? Can 9 be factored?
Yes.
To what?
3 times 3.
3 times 3. Okay? Those are the end of my tree there. So 3 times x times x times x. Now that's what we did right above this, correct? Now we have to find the greatest common factor of these two monomials. Well, we're going to mark off what we can pull out of both. I can pull out a 3. I can pull out an x. I can pull out another x. So my greatest common factor is 3x squared. I cannot pull out, there's nothing else to pull out over here. I cannot pull out a 3 because I don't have another one. I cannot pull out another x because I don't have another one. And that is how you find the GCF of two monomials. Okay, so let's do another one. 25p squared QR and 36pr cubed. I'm going to give you just a minute to start that. Twenty-five p squared QR. 25 factors into 5 and 5. 5 times 5 times p times q times r. 36 can be factored into 6 and 6, which is 2 and 3, and 2 and 3. So your greatest common factors on this one are going to be 2 times 3 times 2 times 3 times p times r times r times r. And I know these are separated. Just make sure y'all. Right. Now, greatest common factor. Okay. Well, first I'm going to pull out 5s. Can I pull out any 5s? No. 2s or 3s? No. No, because I don't have them in both. Okay. Oh, I do have a p, so we just pull out the p. I can't pull out another p. I cannot pull out a q, but I can pull out an r. So your greatest common factor is PR. All right. Now we're going to factor out the greatest common monomial factor, also called the distributive property. Okay, so GCF monomials is what we're going to do. So the steps, you're going to follow the rules to finding the greatest common factor for a monomial. So everything that I've done so far is kind of like the groundwork to make sure that we all understand what we're fixing to get into. Is everybody okay with factoring a number and a monomial first? Is everybody okay with finding the greatest common factor with two numbers or two monomials? Okay. So we're going to follow that step. We're going to find the prime numbers of the coefficient. We're going to factor out the variable. And then we're going to divide each monomial by the GCF so that you're going to end up with the GCF. So let me show you here. So what's going to happen is once we do this, we're going to have the GCF times the monomial divided by the GCF plus the monomial divided by the GCF. Now, once we divide the GCF into each monomial, okay? Because remember, the GCF is terms out of those monomials, correct? They're common terms that we're pulling out. We're going to end up with a GCF times a term plus a term. Okay, we're not going to have any fractions at that point because we're going to pull out the common factors. All right? I promise. It's okay. It's not near as difficult as what you're thinking. Here we go. Number 1, 12x plus 42y. That's a weird looking 2, sorry. 42y. Okay, we're going to factor each one. Here we go. My first term, remember, here's a monomial and here's a monomial, right? Are y'all okay with that?
Yes.
All right. 12x. 12 can be factored into 2 and 6, 2 and 3. So it is 2 times 2 times 3 times x. All right. Now we're going to factor 42y. I did 2 and 21. And then 2 does not go into 21 evenly, but 3 times 7 is 21. Nothing else goes into 3 or 7, okay? So besides itself. So we're going to use 2 times 3 times 7, okay? So now what do we do after we do this step?
On the GCF.
GCF. GCF. All right. So we have a 2 that we can pull out.
She forgets a y.
Oh, times the y. Good job. Thank you, class. Okay, so we can pull out a 2. We can pull out a 3. Now, can I pull out anything else? Can I pull out an x? A y? No, because I don't have the same variable. So this equals 6. All right. So here's this whole step 2 right up here about the monomial and the GCF, okay? So I'm going to do a little squiggly line and write step 2. All right, we can do this. Are y'all ready? Here we go. We are going to write, can y'all see? I need to zoom that in for y'all. We're going to write out this part. We're writing this part out, okay? What's my GCF? 6. What's my first monomial? 12x